Hello, I'm Dr. Randy Kearns, your professor for management 4450, 5450, and our lecture today deals with flooding. So the key terms that we want to be sure and cover, we want to talk about storm surge. Storm surge and coastal flooding is really one of the most significant threats that we face involving a hurricane. We've talked a little bit about it before, but I've got some additional slides later on that will cover a few more of those details. We want to be sure and talk about the difference between a flood watch and a flash flood watch, and a flood warning and a flash flood warning. We'll also talk about the difference between a flood and a flash flood. While we don't have arroyos here in Louisiana, areas out west may have water-carved gullies, typically a dry river or a dry riverbed. But the point to an arroyos is just understanding that areas that see very little rainfall, when they have a substantial amount of rainfall, they can have a substantial amount of flooding that happens very quickly. And again, we'll talk about this shortly. Geology, just understanding what geology is, geography the same way. I think topography I've got coming up in a minute, but when I talk about geology, I'm talking about the Earth's physical structure. When I'm talking about geography, really the physical features of the Earth and how things interact in a way that leads to certain types of flooding events. An ice jam, obviously not something that we're going to be concerned with in New Orleans, but in terms of an ice jam leading to flooding, I do have some examples of that, and we'll talk about that at least briefly in the presentation. Inundation can occur in a number of ways, but the whole point with inundation is how an area is saturated to the point that it's oversaturated, and then what type of problems and complications can arise from that. River flood, again, the cyclical nature of a river, living close to um, the largest river in North America, and actually the second longest river in North America. The Missouri is actually slightly longer than the Mississippi, but the Mississippi has a much greater amount of water for a number of reasons. For one, the Missouri empties into the Mississippi, but then a number of other rivers empty into the Mississippi. But the whole point is what river flooding is, soil percolation. Uh, if you live in a rural area, you would typically you'll typically need something called a perk test, and what they're doing is they're testing the permeability or the water absorption rate of the property. If you don't live in an area where you have sewer provided, again, if you live in a rural area, you'll need to have a septic tank to be able to have toilets, and a septic tank has to have lines that uh, the water runs off of from the septic tank and can leachate into the ground. A soil percolation test is done for that. The reason we do percolation tests, though, or perk test in areas other than where we need a septic tank, it's also important to know what type of absorption does occur or doesn't occur in certain parts of the city, as an example. Again, I'll talk about it more when I get to that point, but just understand a significant part of the city was built on sediment and what some refer to as river mud or clay. Just understand there's not a high permeability associated with that. So there's the even when we do have rainfall, it doesn't absorb well because of soil percolation. Storm surge, I mentioned earlier, again, we refer to that as coastal flooding. I'll go over that more in detail shortly. Topography, we want to think about in the context of geography and geology. Topography is really the layers of the height and the steepness or how flat an area is. When we talk about the topography, we're talking about height above sea level in most cases. But if you're looking at a topo map, a topographical map, there's lines that differentiate different height levels. And on a topo map, if the lines are very close together, that gives you an idea that that particular area is quite steep. Where there's a lot of steep areas and a lot of rainfall, there can also be a lot of flash flooding. Again, something we'll talk about when we get to that point. Urban flooding is particularly profound because there's far less permeable areas. We've managed to cover significant portions of the city of New Orleans, as an example, with concrete and asphalt. And just understand, the more we build these man-made structures that have little to no means of water absorption characteristics, the more urban flooding that we're likely to have. And then water table. Water table is where, so the distance between the surface of the ground and where the water table is located also gives us an idea of how much permeability we have or how much saturation can occur. If there are real limits to saturation, because the water table is really close to the surface of the ground, again, we can reach permeability very quickly, and it can lead to significant amounts of flooding in a short period of time. Again, with New Orleans, all of these things kind of conspire to create challenges for us. The water table is very close to the surface. We have a lot of non-permeable surfaces because of how much paving that we've done. The soil composition is such that perk test is very poor. So again, things that we'll discuss as we get to those parts of the presentation. If we look at the top 10 disasters of all time, and I'm ranking these based on the number of deaths that have occurred, although typically the word that you see that kind of jumps out at you is earthquake, just understand the number one and number two deadliest causes of natural disaster producing the greatest number of deaths of all times include floods. And so flooding is a problem. It's really a profound problem in the United States. Certainly in the greater New Orleans area is a substantial problem. And we have several different risks for several different reasons or hazards that can produce flooding for us. So when we talk about floods, let's kind of go over some of the key facts and then talk about how some of these principles apply to New Orleans. Let's start out with some floods develop slowly, may occur with a constant rainfall over an extended period of time. Some may occur very quickly because of a significant rainfall in a short period of time. Flash floods can also occur in areas where there's not a lot of runoff or a lot of capacity for runoff. And again, the compounding nature of just how New Orleans is constructed puts us at substantial risk from time to time for flooding. It is important to remember that most areas, most communities have some risk of flooding. Areas that are far more likely to have flooding, the coastal areas, something that's called a floodplain. It's important to understand that as much as we think about, significant portions of Louisiana is within a floodplain, just understand that that's also the case for other states. The state of Florida, as an example, more than half of the state of Florida lies within some type of a managed floodplain or an identified floodplain. So we're certainly not unique here in Louisiana. But because of the Mississippi River and the Delta and how that has kind of created land over thousands of years, the coastal plain here is very close to sea level. And so, and thus the water table is very close to the surface. And so there's not a lot of room for the water to go. Anytime a body of water covers dry land, that's what we refer to as a flood. It is the most common hazard that we face. 75% of all federally declared disasters have some aspect of flooding. Maybe flooding is the only reason, maybe flooding is part of the reason, but 75% of all federally declared disasters have some aspect of flooding associated with it. Again, it could be local, it could be widespread, may develop quickly or may develop slowly, again, depending on the nature of what's causing substantial amounts of water to come into a particular area. Heavy rainfall can certainly be exacerbated by things like runoff, what the absorption characteristics are, what type of flood control measures exist. We do have substantial flood control measures in New Orleans. When they're working at peak efficiency, they can control significant amounts of flooding. Just understand that there are many things that conspire to create the threat from flooding in New Orleans, and we'll continue to talk about that. But again, part of it's the soil composition, part of it's how close the water table is, part of it's just how much rainfall that we have from time to time in total volumes of rainfall. Days of rainfall, as an example, so I compared New Orleans to Seattle. If you've ever been to Seattle or Portland, you'll know that both of those cities have rainfall. There are many days of rainfall that exist in both Seattle and Portland. And so if you look at the number of days that it rains, the number of days that it rains in either of those cities is substantially greater than the number of days that it rains in New Orleans. But the cumulative rainfall, the total amount of water that falls each year on average in New Orleans is greater than it is in either Portland or Seattle. And so while it doesn't rain as often here, when it does rain, first of all, it does rain fairly often, and when it does rain, we're far more likely to have substantial amounts of rainfall that can lead to significant flooding. So let's take a look at a river and talk about how the water table lines up with the river and what the unsaturated zone is, and then talk about how over time natural levees are created around a river. So this graphic gives us an idea of how things look before a flood, and then during a flood. What happens is sediment is deposited along the edges of the area that's the typical boundary above the river. And then as water subsides, it actually creates somewhat of a natural levee that exists. Now, these natural levees are only good for short periods of time. Obviously, they need to be built onto for any type of meaningful levee to exist to protect an area from a flood. But it does give you an idea of how sediment is deposited on the banks of the river, and that actually, if you look up and down the Mississippi River, there's substantial amounts of what we refer to as Mississippi mud or sediment that's been deposited there from the river leaving its riverbank through the last hundreds and thousands of years. So when we think about how the water table interacts with nature, and then if we're drawing substantial amounts of water out of that water table, what that does, that leads to a dry riverbed. It can lead to drying out of the swamp. I'll talk a little bit about what we did here in New Orleans over the last 150 years that really changed the water table in a pretty dramatic way. This particular slide basically shows us how the water table, again, interacts with an inundation area and a river, and how the water table is close to where the level of a river typically is. So with a natural floodplain, we have wetlands, and wetlands actually create runoff areas for when flooding occurs. The more wetland area that you have, the more opportunity you have for floods to occur and spill over into those wetlands. We've developed a lot of the floodplain, particularly around New Orleans. In fact, I've got some fairly substantial graphics that we'll discuss shortly, but show how we've fully developed what was once the floodplain, and certainly, well, it still is the floodplain, but what was once wetlands, and turn that into land that we've built houses on, and businesses and roads. And but a part of this, though, is to create, so I talked about natural levees. We've since gone over top of the natural levees and built dikes. For many years, we felt like earthen dikes were sufficient. As we've seen countless times, they're not. And so we have to look at ways that we can reinforce the levee system to be sure that we don't have spillage over into the developed territories. Just understand, though, that when there is wetlands, there's an opportunity for the water to be absorbed in the wetlands. When there's no wetlands, what this really shows us is that discharge can be rather drastic, and the amount of flooding can be, again, cyclical, short period of time, but can be fairly substantial in that short period of time. This just gives you an idea of soil composition. Just to understand that most of our soil around New Orleans is not sand. Most of it is clay or some type of clay composition. It does not percolate well. It does not absorb water well. And that's the places that we haven't covered with concrete, or we haven't covered with asphalt. And so, areas that we can help ourselves includes, how much sand can we put in certain areas to, again, create space for water to be absorbed. When we talk about flood hazards, what are things that we can do, certain protections that have been put into place. I've got some examples coming up that I've got some images of, but diking and embankments. The whole aim to this is, again, creating protection for a given city or a given community. When we build up those dikes or those embankments, again, the bigger concern is, are they going to withstand certain types of flooding? And if they don't, what type of challenge can that create? Channelization, I've got some images coming up for channelization. The best way to think, though, of channelization is when you think about the channel that sits really on the north side of the University of New Orleans. That is a channel that allows water to rapidly move out of the city and can be pump assisted out of the city. It is gravity fed, but it's also pumps can be used to assist the gravity distribution of that water out into Lake Pontchartrain. Diversion, the best example of diversion is the Old River complex north of Baton Rouge, the Red River floodway. We'll talk about that later on also. And then storage structures. We don't use a lot of storage structures here in New Orleans. The only hydroelectric dam that actually exists in the state of Louisiana is a part of the Red River and the Old River flood control area north of Baton Rouge. There are some states that have substantial amounts of dams that have been put into place, in many cases for hydroelectric power, but also for flood control. And where those dams exist for flood control, they create substantial reservoirs. So here's some examples of a dike. The Huang River in China has been diked since at least 600 BC. Multiple avulsions where, and an avulsion is where the water comes in contact with, and that friction causes the bank of the river to break away to the point that the water overtops the bank and then moves into a given area. Maybe a town, maybe a community, maybe a neighborhood. But again, the example that I used in 1887, a 22-meter dike was breached and 900,000 people drowned. In 1931, 3.7 million people drowned by floodwaters. So just understand, in many cases when we try to control a river and we use dikes and a levee system or some type of channeling system, the aim is to help keep the river within a certain path that it has remained in. Just understand that if there's an avulsion that takes place, it could change the path of the river. In fact, I'll show you shortly how the path of the Mississippi River has changed literally dozens of times over the last 200 years, and how that has reshaped some towns, and in some cases caused some towns or ports to go away because the river doesn't go there anymore. And so there's a lot of controversy about channelization, or how do you control a river, and there's a lot of debate about it and a lot of dispute about it. Just understand that managing a river is a substantial undertaking, and because of the nature of how much water is discharged through a river, that water is quite powerful. And so how do we control that is quite challenging for much smaller tributaries, much less something as substantial as the Mississippi River. When a channel avulsion occurs, a river can rapidly abandon the typical channel that it has been within. The avulsion can lead to a new channel being created and a new direction flowing for the river. One particular example that I have provided a video of is a professor from LSU who talks about the potential for the loss of the Old River Control Complex, how close it was. Arguably, some feel like it was closer than others, but the 2016 flooding of Baton Rouge, how much damage could that have caused to the Old River Control Complex? Just understand that flood control complex that's there, and it's north of Baton Rouge, purposefully controls how much water goes down the Mississippi and how much water is diverted over to the Red River and the Atchafalaya River. That outflow channel right now, by designation, it receives about 30% of the water from the Mississippi River. The other 70% stays within the Mississippi River. Just understand that it is a much shorter line from north of Baton Rouge to Morgan City, going straight down the Atchafalaya River. And so if we did lose control of the Mississippi at the Old River Complex, because of flooding, flooding was able to inundate the area, and avulsions occurred that redirected the river. If the river ever redirected itself into the Atchafalaya, it would be very, very difficult to redirect that water flow from the Mississippi back into what today is the current path of the Mississippi River. And what does that mean? That means every city south of there, New Orleans, Baton Rouge, and all places in between, would lose its source of fresh water. And obviously, without fresh water, you can't have a population in those communities. So obviously, this is a really profound threat. But at the same time, I am told that it is being managed reasonably well, but it's obviously a concern that does exist. Channelization, here's just a couple of examples of channelization. Channelization does allow us to rapidly move water and discharge water from one part of the city to, in most cases in New Orleans, we're rapidly discharging water out into Lake Pontchartrain. But the whole point to channelization is to allow gravity to help water move quickly out of the city. And channelization does give us a way to be able to collect that water and then rapidly discharge it. In some cases, it's pump assisted, but certainly in all cases, the aim is to rapidly get the water out of the city. Channel avulsion. So let's talk just a little bit about channel avulsions. When you look at this image, you really, nothing immediately comes to mind other than you see the town of Natchez, Mississippi, and the Mississippi River. Let's look a little bit closer, and if we look a little bit closer, you'll see how the river has, through avulsion, has redirected itself here, allowing parts of the state of Mississippi to actually be west of the Mississippi River. And so what that tells us is the flow of the Mississippi River at one point followed this path. It's still titled Old River. Just understand, because of the change of the flow of the Mississippi River, that area is no longer riverfront, or it's certainly no longer a part of the Mississippi River. And actually, if you look for towns up and down the Mississippi River, you'll see examples of towns. Some are ghost towns today. Some are underwater. Some just disappeared because the river, the path of the river changed. But sometimes we think of permanence. We think of the Mississippi River. It's always flowed through New Orleans. Well, it has for the last, I don't know, 1,000 years, certainly since before the city of New Orleans existed. But there are a number of places we've done a lot to try and control the flow of the river. There are a number of places we haven't done as much to control the flow of the river, and where we haven't, a number of these changes have taken place. I've got a few more examples of this. This is another example of where, again, if you look, you can see how the river at one time moved around this particular piece of land and flowed back here. And then at some point, again, water is going to follow the path of least resistance. At some point, it's going to continue to just its general nature to potentially straighten itself out. And so that's what it does. It's going to look for, if the path of least resistance means that what had historically been a river path here now becomes a river path here, it means the area that may have set along the riverbank here no longer sits on a navigational waterway, or it may be a lake, or it may be just a dried up riverbed today. Vicksburg, Mississippi is really the best example I can offer of how a city had an avulsion that caused it to, for a time, substantially lose its attractiveness as a waterfront port. The city of Vicksburg at one time was a really substantial river port on the Mississippi River. On the left is the map of the Mississippi River, the city of Vicksburg, and this is about 1863, 1864, after the Union had defeated the Confederate troops there in Vicksburg. But again, this kind of gives you an idea of the layout of the city. And it gives you an idea of how substantial the river was and how the city was really an ideal site, an ideal port city on the Mississippi River. Well, in the early 1870s, it was noted that water from the Mississippi River was beginning to, this area was becoming avulsed, and water was beginning to seep across to here. And then in 1876, April of 1876, there was a flood and the river changed its path, and all of this area basically became, this is referred to as Centennial Lake for 1876 when America was celebrating its centennial. But this is basically a much smaller body of water that's rather docile. It doesn't include the Mississippi River today. So much so that the Corps of Engineers wound up building a rechanneling this particular river. What's the name of that river? It'll come to me in a minute. It's the Yazoo River. So what they wound up doing was dredging out the depth of the Yazoo River and creating this much deeper canal just so they could resurrect at least a part of the port aspect of the city of Vicksburg. Well, it took from 1878 when this started. So again, the port pretty much ceased to exist, or the river basically went away from the port in 1876. In 1878, they started the project of trying to dredge out the Yazoo River and create a much deeper channel, a deeper canal, so they could expand the port back to the city of Vicksburg up the Mississippi River. And you can see that here. And it was not until 1903 when they were able to reopen the port. Now, over 25 years, you can imagine how much business went away, or how much, people adapt to different things. They learn new ways to do things. And so the city of Vicksburg never fully recovered from what it once was. Between the destruction of the city during the American Civil War and certainly the loss of the port for about 25 years because of the change of direction of the Mississippi River, because of channel avulsion, that's caused mostly the demise of Vicksburg. It does exist today, but it's far more of a quaint city that has some port activities, but far less port activities on an order of magnitude compared to what it was in 1860, even 1865. If we look at dams, again, the only hydroelectric dam that exists in Louisiana is a part of the Old River Complex north of Baton Rouge. Most of the places where there are large dams, they're typically built for generating hydroelectric power. The tallest dam in America is the Hoover Dam. It's on the Colorado River. and it sits on the state line between the state of Nevada and the state of Arizona. The longest dam, or technically the largest dam in America, is actually on the Columbia River in the state of Washington, the Grand Coulee Dam. And then the largest dam in the world is the Three Gorges Dam that just opened over the last 15, 20 years in the Yangtze River in China. Again, these are massive, all three of these are massive structures. The Three Gorges Dam is truly a massive structure, but when we build these large dams today, one of the most important aspects of it is how much engineering goes into trying to be sure the dam is able to withstand a lot of different challenges that it may face during its lifetime because of how much water is being held up by the dam, and then how much subsequent flooding could occur if that dam would fail. So let's talk about frequent flooding in New Orleans. We have everything going against us. We have lots of impervious surfaces. We've managed to put concrete and asphalt on many of our surfaces. And even where there's exposed soil, most of the soil is clay and does not percolate well. It does not allow water, it does not absorb water very well. And even if it did, the water table is very close to the surface. And so somewhere between the water table being close to the surface, the clay subsoil, the impervious surfaces, those three things conspire to really create challenges for us. I'll also talk about how the swamp was drained, and we created a lot of reclaimed land shortly, because that actually had a purpose to it, that had intended consequences as well as the unintended consequences. So I think I've shown you this image before, but the main point I want to make here is if I looked across the Gentilly Ridge over to the University of New Orleans, and then to my left, as you're looking at the screen, I saw the Mississippi River. Again, just understand the height of the Mississippi River above sea level is, it's necessary for it for water to flow downhill to the ocean. Obviously, that makes a lot of sense. Lake Pontchartrain, on the other hand, is very close to sea level. It's actually several feet above sea level, but not nearly as high as the Mississippi River. But it's also important to point out that aside from the natural levees that were created over time by the Mississippi River, leaving its river banks, depositing silt and mud, and then that water drying up and leaving that in place, it created some natural levee. We also have built on top of those natural levees, and in many cases reinforced them with substantial amounts of concrete and steel to also further contain the river. And the point is, it's created a much higher protection flood wall that does exist today, at least after Katrina. We've also rebuilt and reinforced the flood wall out on Lake Pontchartrain. But if we look at the cross section, if we look at the topography, our topographical lines are going to tell us that there's some parts of the city, about just over 50% of the city, lie below sea level. And so when we talk about an area being below sea level, it's important to keep the water out, and it's important that as water is collected inside of this area, rainfall as an example, that we have an elaborate pump system to pump it out. And that's what we do. We pump it into some of the channels that we've constructed, the channelization that I've talked about earlier, and then because it's pumped high, then it allows it to gravity feed out into Lake Pontchartrain. In many cases, though, this kind of cutaway image gives us an idea of the bowl effect that does exist here in New Orleans. So this is an image of the greater New Orleans area that we would consider today. This was a survey crew in 1849. Just if you look at the area that was developed down close to the river and the area that is identified as swamp, you see a substantial amount of the areas identified as swamp or swamp forest. And so the one way to think about it is over time, we have managed to drain all of the swamp area. We've managed to, we created this really elaborate drainage system to drain the swamp, so to speak. It allowed the city to expand. It allowed us to move communities out into those areas, build homes and businesses. But another way to think about this, though, is swampland is best described as a sponge. And if you take the water out of a sponge, what happens to it? It contracts. And in some cases, it contracts in a pretty dramatic way. Much of the area around Claiborne, over to Gentilly, and then much of the area in the east and the lower Ninth Ward, all of these areas are areas that are in many cases below sea level, and in some cases substantially below sea level. Again, if I go back to well, I can't go back to the other image, but the other image that I showed you a few minutes ago, it's important to remember that a majority of the city was near the riverfront at that time. The riverfront was the area that was most protected from flooding, just simply because of the natural levees that existed and some of the man-made levees that had been built. I might also add that what was once the city of Carrollton at that time was the county seat where the courthouse was for Jefferson Parish. But the city of Carrollton sat in a area where a natural avulsion occurs. If you look at the topography, if you look at a map of the Mississippi River, you'll see there's a bend in the river near Carrollton. Well, that avulsion took place multiple times, and because the city of Carrollton did not spend a substantial amount of money to protect the city itself, avulsion would occur, flooding would occur, but the Carrollton area is actually higher than the city of New Orleans, and so what would happen is water would leave the Mississippi River, come into Carrollton, and then actually flood substantial amounts of New Orleans. So much so, and New Orleans at that time was politically powerful enough to say, we got to stop this. The city of New Orleans annexed the city of Carrollton, including the courthouse of Jefferson Parish at that time. It was interesting dynamics and how politics worked. But if you're ever in Carrollton, if you'll notice the old courthouse, which has now been turned into an assisted living facility, that was actually the courthouse for the Jefferson Parish. And the city lost its right to be a city and was absorbed into New Orleans simply because they couldn't manage their flood control and the avulsions that continued to take place and the flooding that continued to affect the city of New Orleans. So there was an engineer who designed a screw pump, and this is an example of one of the multiple screw pumps that exist around the city. There are almost 200 of these types of pumps. It does give you an idea of how substantially, how large the pump is, and how much volume of water it can obviously pump, so long as it has an electric source and is working appropriately. It's referred to as a screw pump Sometimes it's referred to as a wood pump. To begin with, I couldn't figure out why it was a wood pump until I realized that the engineer that designed this particular pump, his last name was Wood. But again, it does give you an idea of just how dramatic and how large these pumps need to be able to pump out substantial amounts of water out of the city. And so after Hurricane Katrina, a really profound effort was made to um, um, substantially control the perimeter of the city of New Orleans. Now, we still haven't done a good job of compartmentalizing the city, but we have done a good job of encircling the city. And so much so that by encircling the city and hardening that perimeter, I mean, we've spent so somewhere between 14 and 17 billion dollars building this really elaborate system, but it does allow us to, in a pretty dramatic way, encircle and keep the city reasonably safe, particularly from storm surge and other types of flooding that may occur either off of the Mississippi River or storm surge water being pushed up the Mississippi River from a hurricane or into the city from Lake Pontchartrain, again from a hurricane. Um, uh, to the point that it was believed that even during Hurricane Ida, had the storm shifted, there may have been some overtopping of the levee in a couple of places, but it would have overtopped in areas. Again, all of the levees now are rated at a much higher capacity in terms of their ability to withstand flooding today than what many of the areas were in 2005. And this is just, again, giving you an idea of the magnitude of the system that exists and just how far-reaching and how substantial the system is. It does completely encircle the city and the area that's within a flood protection area. I might add, this particular point is a swing gate that can be closed off. This area can be closed off to stop the water flow coming up from storm surge. Again, just another area that shows flood control measures that are in place. So types of flooding, saturated flooding, flash flooding, storm surge, and levee failure. There's a book that I use that also talks about monsoonal floods. That's not a threat that we face here in the United States. I included it just for the list, but not because I'm going to go into any type of detail about it. General flooding, again, rainfall intensity and duration, soil composition, water table, and then other parts of the country, snow melt, but certainly here, storm surge, tropical storm surge, dam failure, levee failure, and then because of the amount of impervious ground cover and how much we've done to either pave areas or put down large amounts of either concrete, asphalt, something that's an impervious ground cover. With saturated flooding, this is just an example of the saturated flooding that occurred in 1993. If you'll look at the area south of the state of Minnesota, northern Iowa, over here on the Nebraska state line, but mostly here between Minnesota and Iowa, you'll see how much flooding took place to the extent that it appeared to look like it was a sixth Great Lake that had been created. But there was a substantial amount of flooding that took place, dramatically oversaturated that particular area. The saturation flooding, again, substantial amounts of rainfall, only 50 deaths, but thousands of people were evacuated. Substantial amounts of crop loss, housing destruction. Some claim this was the 500-year flood. but it was 2 months of flooding. It was dramatic, and it was sustained over over an extended period of time. Saturation flooding can occur from tropical systems. This is from a presentation I've given before. Hurricane Floyd affected eastern North Carolina. Honestly, another example, and probably a better example today, is Hurricane Harvey and the impact it had on the greater Houston area. But the whole point and with Floyd basically surrounded a city with water. The city of Greenville, which was 20, 30 miles inland from the Pamlico Sound, much less the ocean itself. But it inundated an area in such a way that it was not accessible. You could not drive to it. So much so that there were people that you know, they may have stayed at work, and the hurricane itself had lost a substantial amount of wind speed, and so the wind power of the hurricane was really not substantial. I don't think it was. It may have been a strong Category 1 or a weak Category 2, but at one point it was considered to be of great concern. It really troubled weather forecasters as it slowly moved up the Atlantic seaboard before it finally came ashore. But it was a much weaker storm when it came ashore, but it still had collected all of this rainfall potential that it deposited on eastern North Carolina, much like Hurricane Harvey did over Houston. And so when you have that type of saturated flooding, it can be really dramatic and can be quite profound. So a flash flood is a life-threatening flood that begins within 6 hours of a rain event. That's our definition for what a flash flood is. It's typically associated with some type of a defined body of water that may spill out over its banks. Sometimes it can be in areas that are normally dry, such as Arizona, New Mexico, Nevada. But sometimes it can be in areas like the Midwest. We see flash flooding in a number of states, as well as certainly in Louisiana and certainly in New Orleans. You know, a flash flood can occur in any location where there's not sufficient runoff opportunities for the water to be absorbed naturally, such as wetland areas. Also in our flash flood definition is rapid inundation of areas that are normally dry, underpasses, roads, buildings. You know, later on when I talk about business continuity, you know, if you are going to operate a small business in the greater New Orleans area, we need to think about preparing for flash flood. And we need to talk about how we can design our businesses and our homes in a smart way if we're going to be in a floodplain. And then what's the difference in being in a floodplain, and what are some areas of the city that are safer than other areas? Just understand the power of water is really profound. It can move substantial buildings, cars. There are lots of things that can move in a short period of time. Although we really don't have nearly the problem here that they do in areas more prone to wildfire. An area that's been affected by a wildfire, if there's a substantial rain event in that area in the months following the wildfire, you can have catastrophic mudslides associated with flash floods, just simply because there's no longer the vegetation there to be able to collect the rain and to hold the rain in place. And instead it facilitates this rapid runoff, turning into a mudslide and turning into a catastrophic event. Ice jam flash flooding, it's basically where ice sheets form, they break up as there's thawing that takes place. But as that ice flows downstream, It may impact a certain area like a bridge or something that's impeding at least part of the water flow in an area. But an ice jam can occur and can lead to flash flooding. Again, this is an area, or this is a problem that's primarily seen more in the Midwest and the central north of the United States. It's obviously not a problem that we're going to deal with. Storm surge is really our biggest threat aside from flash flood in the city of New Orleans. Storm surge is a problem that we associate with tropical cyclones. Storm surge it is really affected by several different factors: the speed of the storm, the intensity of the storm. Does the storm come ashore at high tide or at low tide? Knowing where we are with the tides is important. What type of wave setup? I've got some images shortly, and we can talk about that. Angle of approach to the coast. What I mean by that is, again, is it impacting us directly? Again, if we think about the counterclockwise circulation of wind around the eye of the tropical cyclone or the hurricane, where is that kind of northeastern wall of the hurricane, and what is that impacting as it's approaching? And then the continental shelf. If there's a shallow slope, there's a greater surge. Areas around the Mississippi Delta, which is the mouth of the Mississippi River, much of the coastal area of Louisiana, there's a very gradual continental shelf there. Other parts of the country, there's a much steeper continental shelf, and where there's a steeper continental shelf, there's less storm surge in that area, or the storm surge is less profound. Let's look just a little bit at what storm surge is, and then notable examples of storm surge. And so, again, with a hurricane, you have a tropical cyclone, you have really a lifting of the water as this very large, massive storm passes over the surface of the ocean, and then you have wind blowing across the top of the water that's pushing it as it approaches shore, that's pushing it inland. And again, the best way I can describe it for you so that it's easy for you to understand is to hold a cup of water that you feel close to the top but isn't overflowing the cup, and then blow across the top of the cup of water, and you can blow water out the other side. And that's the best way to think of how storm surge occurs. Again, factors depending on how much, what the millibars of pressure, the lower the millibars of pressure, the higher the updraft that exists within this. This pressure is going to drive a part of the storm surge. The wind is going to drive a part of the storm surge, and then the tides are also going to affect the level of the ocean at the time that it comes ashore. So I mentioned earlier sea level. Sea level is going to be affected by the tides. Storm surge is going to be on top of sea level, and then wave setup will certainly depend on how destructive the force of the ocean is as a part of storm surge. And then another challenge, or another thing that we can do to protect ourselves, is how much elevation we have above sea level. And then is the structure elevated? But let's kind of go through some of these images here quickly to look at the comparisons. This just gives us a better image of wave setup and how much wave setup can, again, contribute to storm surge. And then this looks at the difference between normal tide and high tide. And then sea level contribution, as well as storm surge and wave setup, again comparing it with elevation above sea level. And then this is using the word inundation to help us understand that inundation is the depth of water over what normally would be dry land. So again, we've got sea level, high tide, the effect of the tide, storm surge, wave setup, and then graphically showing us what inundation is. And then total inundation or total possible inundation at any given location is really including all three of these factors: storm surge, tide level, and wave setup. And again, this just gives us another image of what that looks like. And so the last of the flooding that I want to be sure and talk about is dike and dam or levee failure. If we look at levee failure or dike failure in the United States, obviously the most recent failure that was the most profound was here in New Orleans in 2005 following Hurricane Katrina. Again, it's important to note that Hurricane Katrina was more of a man-made disaster exacerbated by a natural disaster. So when we look at dam failure in other parts of the country, again, we're typically talking about hydroelectric dams or in some cases earthen dikes. And let's look at a couple of those examples, but let's start out with here in New Orleans. In New Orleans, there were just over 50 failures of the levee system. Now, there are some areas that were, that had a lot more notoriety to it than others. But I think the main thing that you'll see out of this is much of New Orleans East was underwater. Much of St. Bernard Parish was underwater. Much of the Gentilly area over into the Claiborne area was underwater. The areas that naturally are above sea level are the areas closest to the river. And sometimes it seems counterintuitive to think that the closer you are to the river, the less likely you are to be below sea level, but that is true. Again, if you think about the height of the river that it needs to be for the water to flow downhill to go out to the Gulf of Mexico, the river is going to be much higher. And so the closer you are to the river, the higher you are going to be above sea level in the city. And then this is just a satellite image of the areas that were flooded. You'll notice the dark areas that were flooded. The best way to think about this is Lakefront Airport. This is the University of New Orleans. Again, the Gentilly area, New Orleans East, Lower Ninth Ward. But this gives you an idea of the area. Again, the closer you are to the river, the higher the level of the property, and the less likely you are to be threatened by flood. And that's just simply because of topography. Those areas are well above sea level. I lived near Tulane University, and we bought our house here primarily because the house itself sits about 8 foot above sea level, and that's substantially. We actually had intended to buy a house out close to the university, but the house itself was in a floodplain. The more we thought about it, and the more we talked about an elevated structure and what that would mean, and how much of a challenge that could be, the more we realized we needed to kind of rethink what we were doing. Let's talk about dam failures just a minute around the country. Really, the most dramatic was the Jonestown flood. It's covered up, but I think it was 1886 maybe, but this is in Pennsylvania. The Jonestown flood was really dramatic in a number of ways. This was a large earthen dam that had been built and then had been added onto Okay, 1889, but had been added onto several times. But it was an earthen structure, and there was a substantial amount of rainfall that wound up leading to an overtopping of the dam. And because it was an earthen structure, the area started to erode away as it was overtopped, um, and the area downstream was the city of Jonestown. Population was about 10,000. The surrounding area, 15 to 20,000 people. Um, the flood itself occurred 4 p.m. on May 31st. This is kind of the aftermath of the storm. It's believed that just over 2,000 people were killed, although if you look at information from that period, you'll see those numbers can be as high as 10,000 were estimated to have been killed. Again, the numbers are really inexact science, but does give you an idea of just the magnitude of the damage that occurred. The city south of the dam was completely wiped away. And as I say, it was a city of 10,000 people. This gives you also an idea of what the city looked like. Um, and just, again, some additional images and how truly catastrophic it was. Um, Um, let's get a little bit closer. This is 1977. There was a tropical storm that really never materialized, but it came ashore in eastern North Carolina, then moved up over Virginia, and then the center of precipitation actually um, stalled out over the mountains of North Carolina. Now, if you think about lines of topography in a mountain area, any mountain area, and the mountains of North Carolina are no different than that, you have an area that potentially can create a lot of runoff and the potential for a flash flood. And that's what occurred here in 1977. Rainfall that extended over a period of time. Um, and then downstream from this was the Kelly Barnes Dam. The dam failure was at a place called Toka Falls. There was a college downstream of the dam, the Toka Falls College. Most of the people, there were 50 people killed from the flooding. Most of the people killed were students in their residential dorms at Toka Falls. Um, um, the fragmented response was fairly substantial in the fact that there were a number of federal agencies that showed up, none of which really had a good feel for what they were doing. The president at the time was Jimmy Carter. Toka Falls is in northern Georgia. His wife Rosalind and Jimmy at a time had been the governor of Georgia, and so it's safe to say he was not pleased with the federal response. So much so that the byproduct of just how poorly this response was the creation of FEMA and bringing together several federal agencies to be sure that we don't wind up with federal agencies on the scene of a disaster trying to figure out who's in charge or who's responsible for what needs to be done. Now, again, as a reminder, all disasters are local, but when you're calling in for federal assistance, the feds need to have it together, and they certainly didn't then, as they haven't at times, at other times. These are just some other images from Toka Falls. Um, Again, just giving you an idea of the magnitude. The college was substantially damaged, and 37 students at the college were killed. Um, During a flood, the main thing to be aware for watches and warnings. Watch conditions are favorable that something may occur. A warning, something is happening. Again, understand where you are geographically. What's the topography of the area you're in? Are you in a floodplain? What type of floodplain are you in? How prone are you to flooding? During any type of a flood event or any type of a disaster event, Pay attention to what's going on. Be ready to move to high ground. Be ready to evacuate if that's what you need to do. If you do need to evacuate, don't walk or swim through floodwaters. Stay off of bridges, fast moving water. Stay away from waterways. Pay attention to barricades. Don't drive around them. The number of people that I was involved in providing rescues for that drove around barricades are more than 10. So these things can happen quickly and can be difficult to manage and difficult to deal with. Again, there's lots of rescue capacity, but let's not test it. Let's look for areas that we can be prepared and that we know what we're doing. If you need to evacuate an area. If you're in a floodplain, understand what that means and what your risks are. It's always important that first of all, typically we try not to split people up. We certainly don't want you to split up as a family. Sometimes circumstances are beyond your control and that happens. One of the things for a family disaster plan that I would always encourage you to think about is a rally point. If we do split up, where could we meet that's a safe place that we could meet? And what does that look like? I mean, for a lot of people, it could be a parking lot at Target or at Walmart. It could be in a town like Baton Rouge, just simply because that's farther away from New Orleans. It could be an area closer to here, but it needs to be something that's familiar, but pre-designate a rally point that allows you to, if you do split up, if you think about the aftermath of Hurricane Katrina, reuniting families was a monumental task. And again, that reminds us the importance of having a good family disaster plan. Again, don't walk through moving water, don't drive through flooded areas. The amount of rainfall it takes to float a car, particularly smaller vehicles that are light, it really doesn't take a lot of water to be able to move a car off of a highway, off of a low water bridge. There were a couple of low water bridges in a community where I used to work, and it was not unusual for us to deal with cars that had gone off into the river because someone had tried to drive across a low water a low water bridge that water was over the top of the road during a flood zone. After the flood recedes, return only when it's safe. Typically, authorities will indicate when an area is safe. Stay out of flooded areas. The amount of damage that can occur, we also need to think about what wildlife may have been moved because of the flooding. This is just one example after Hurricane Florence in North Carolina. First of all, when you look down, this is an interstate highway that's still flooded. As the floodwaters receded, this is how many dead fish were left on the side of the road. It was really substantial that they were bringing out fire trucks to hose down the highway, and you can imagine how it smelled. But it gives you an idea of just how much floodwater was in that area at one particular time. In any of our response to floods or flood hazard, floodplain mapping, land use zoning, flood insurance, abatement. Abatement is really a part of, if you ever get a chance to serve on city council or serve in state government, watershed management and floodplain management is really profound, being sure that we have substantial amounts of wetlands or areas for water to at least be absorbed can be substantial in allowing an area to have some drainage and absorb water for a shorter period of time. Again, if we think back to that graphic, if there's no place for the water to go, the flooding can occur very quickly and really quite profound in a short period of time. Other aspects of this, it's actually the same information we just talked about. Let me move on to this. Flood proofing is really about paying attention where you are in the floodplain. You know, one of the things that I would remind you is you can elevate your home outside of the floodplain. I mentioned earlier we actually considered buying a home in the floodplain with the elevation that would be needed to make it, you know, flood compliant. But then the point becomes, if we need to evacuate that home, we're, you know, if we wait too long, we're going to be surrounded by water trying to evacuate. What does that do to our cars? How much access do we have back to our home before the floodwaters recede? You know, if you can avoid living in a floodplain, I would encourage you to avoid it. If you can't avoid living in a floodplain, or at least one of greater risk, then again, understand what those risks are. I have included the FEMA flood maps. Zone X is the area that's protected by the levee system, and Zone X is there's two conditions to meet Zone X. First of all, it's protected by the levee system. Second of all, it's above sea level in a way that, again, gravity always wins, water always flows downhill. So Zone X is a 0.2% to 1% flood risk, and it's typically area outside of the 500-year floodplain, which 500-year floodplain basically means one chance out of every 5 years, 500 years, or two chances out of 1,000 years for a flood to occur. Now, you know, probabilities and reality sometimes are two different things. Zone AE, areas with at least a 1% annual chance of flooding and a 20% chance of flooding over the life of a 30-year mortgage. There are some realty sites that include something called flood factor. Just understand, if you look at that, all of the city of New Orleans is going to have a flood factor of at least a 7 out of 10, some are even higher than that. If we look at those FEMA flood maps, this is what the University of New Orleans looks like. The area in brown is the area above sea level. The area in blue is the area that's in Zone AE. And again, this, let's see, let's kind of talk about actually off the map here. The university is here. The research center is here. The arena is here. And this kind of gives you an idea of what area lies above sea level and then what area lies below sea level. This is area floodplain X, and this is area AE, or floodplain AE. This is another part of the city, looking at, I think this is Claiborne Avenue here, and then areas north of Claiborne, the fairgrounds type area. You know, personal preparedness, so we've got just a couple of slides to wrap up. It's important to be sure that you have flood insurance. Know where you are in the floodplain. If you can elevate your structure, elevate your structure. If you're buying a home, understand where you are in the floodplain. Think about what's on the first level of your home. Think about, you know, there's not a lot of basements in New Orleans, but think about what type of water exposure you're going to have in those areas. How quickly can you pump water out of those areas? Do you have check valves in your sewer traps just so it doesn't push sewage up into your home? Do you have an evacuation plan? You know, what types of important documents do you have in a waterproof container or a fireproof container? Um, you know, one of the things I would encourage you to do is to think about what are important documents that you need to have to reestablish who you are. Um, if you wind up having to evacuate in your home and everything is lost because of some catastrophic disaster, what can you, in a moment's notice, um, pick out of a safe or some type of safe storage area in your home that's in a waterproof, fireproof container that you can take with you. Again, typically they make these packets or pouches, um, it, and then what types of things that would you need to be able to show this is my property, this is where I live, these things, birth certificates, the copy of maybe an old driver's license, certainly any type of valuables, but what are things that you can take with you at a moment's notice that you can pick up that's in a waterproof container and a fireproof container? That would be an important part of personal preparedness. Then a part of business preparedness, again, protect your equipment. Just think about how you normally store things. If you're on the first floor of any type of property, and particularly if you're in the AE floodplain, um, I would think in the context of what do I have on the floor? Can I set it on a table? I don't know that I would have any computer equipment setting on the floor. Um, whatever you have setting on the floor, you need to be willing to throw away after a flood occurs. And so I, I would think in those terms, and then I would also think, how much am I going to be exposed to flooding? Again, we live in New Orleans. Where we live, certainly where a lot of businesses are, it's not unusual for water to be pushed up into a business in a storefront as water fills the street and people drive down the street. And so, how can you keep water out? And if water comes in, what is it going to damage? What types of construction have you used to make it very simple for you to recover? And then where do you store things so that it doesn't get wet if you wind up with a foot of water in your building or 2 foot of water in your building? One other thing, if you have to abandon an area or evacuate an area, um, one of the things that they make a really nice cover to go over a computer. If you don't want to spend extra money, I would encourage you to go to Walmart, Target, whatever your favorite big box store is, and buy a handful of see-through transparent shower curtains. It's water resistant. It's something you can put over a piece of equipment. I've heard people use trash bags. The only challenge with trash bags is if you don't know what's in it, some people may, as they're later trying to clean up, they may dispose of things that you want to keep. So that's why I would encourage you to buy some cheap $7, $8 shower curtains that are transparent that allow you to see what's on the other side of it, but still protected. But as far as your business goes, again, what type of continuity plan do you have? Supply chain, what type of staff roles? How do you account for your staff? If you have to rapidly evacuate your building, how do you account for the staff that was there, that everybody was told to evacuate? What type of shelter options do you have for them? How quickly can you restart your business? If you needed to restart it somewhere else, could you do that? Would that be something that you need to do? Supply chain, how do you get things in that allow you to continue to do what you're doing? How do you ship things out if you're selling something? Again, restoring utilities, and certainly your critical equipment. All of this gets back to, again, assume 3 feet of water comes into your business. How do you mitigate the damage? What are things that you do to protect the equipment that you have? How do you store things in your office that accounts for that kind of simple flooding that may occur? Obviously, if it's more catastrophic than that, I realize floodwaters during Katrina were substantially deeper than 3 foot, but 3 foot is a good safe level that most of our floods will not exceed. And then the last two slides, historical flooding. There's not a real direct correlation between historical events and future events, other than they do give us an idea of what can occur. We can control floodplain management. We can control construction standards. We can't control geography. You know, we have what we have. We can't control topography. The only way we can control topography is elevating our structures, so through construction standards. But just geography and topography really limit our abilities to be able to control some of these things. And the speed of the storm and the influence of other meteorological events can be profound. And again, if we've lived through one disaster, we've lived through one disaster. It doesn't always tell us exactly how we should behave in the next one. In conclusions, flooding is really the greatest natural disaster threat in the U.S. It's typically a component of other types of disasters, whether it's a standalone event or an aspect of tropical weather. Flooding, though, is a constant, clear and present danger that does exist here in New Orleans and other parts of the country. And again, the three elements that come together: the amount of impervious surfaces, the type of clay, and soil composition, and the shallow water table. And that gets us back to questions. If you have questions, send me an email. Certainly, I know this was a lot longer than most of your presentations, but there was a lot more material to cover. I would spend a little bit of time on the FEMA flood maps. Look at your address and what does that tell you? And again, sometimes the best we can do is just to be informed. There's some things that we can't control, but the things that we can control, we need to at least be educated and understand what they are. Thank you.